One of the main applications of electrostatic accelerators, such as the one at the Ruđer Bošković Institute, is ion beam analysis. Among the most useful analysis techniques is the Rutherford backscattering spectrometry. It is based on the elastic collisions between the light ion beams from the accelerator and near-surface atoms in the sample under investigation. The measured energy of the elastically backscattered ions is a function of the mass of the sample atom and of the depth where the scattering event takes place. This depth can be determined, allowing to profile the element concentration and composition close to the sample surface. The backscattered energy is measured by the silicon-charged particle detector. In the case of single crystal samples, if the incoming ion beam from the accelerator is aligned with the main crystallographic axis, a drastic decrease of the backscattering yield will occur since ions can pass through the crystal lattice without significant scattering. This effect is called ion channeling and can be used to investigate the crystal lattice properties, its quality, defects, crystal morphization by irradiation, elastic strain, etc. RBS channeling is suitable for investigation of single crystal samples with flat surfaces. Sample sizes can range from a few millimeters up to about 1 square centimeter, while their thicknesses could be up to several millimeters. Samples are investigated in the vacuum chamber by exposure to proton or helium ion beams of energies between 1 and several mega electron volts. As a result, the backscattered spectra in random and channeling orientations are acquired by the data acquisition software and saved for later analysis. After the sample has been mounted into the scattering chamber, proton or helium beam with ion currents roughly between 1 and 10 nanoamperes is directed towards the sample. The sample is then aligned to the channeling orientation with respect to the ion beam by changing the azimuth and tilt angles and by collecting the RBS spectra. This is done using the in-house Spectre data acquisition software. The user can then select specific positions on the sample or specific azimuth or tilt angles to collect the RBS channeling spectra. Final spectra carry information about the amount of disorder in the studied material. For example, these results can be correlated to the distribution of vacancies along the sample depth. Almost negligible disorder could be produced at the end of the ion range, but this does not have any influence on the channeling spectra. Unfortunately not, but channeling can also be done using the ion microprobe, in which case the microbeam can be aligned with individual crystallites. For more information, please visit the CERIC website.